We're going to be talking about standard deviation today. And we're talking about how do you find standard deviation. So let's just look at here. If I had information and I'm saying, okay, how often in a month does a group of teenagers text? And I said, how can I get a set of numbers or set of answers from 6 teenagers where for all of these sets the average would be 80 texts per day? Well, the easiest way to do it is to say, well, all 6 people answered 80. The average is 80. Another way to do it is kind of to look at like a little bit below 80, a little bit above 80, a little bit right at 80. So 78, 79, 80, 80, 81, 82. Average of this is going to be 80. Another kind of more creative way is to say we have 3 people answered no, I don't do any texts in a month, but 3 people answered I do 160 texts, and then there your average would be 80. Another way is if 5 people answered 0 texts in a month, but 1 of them answered 480. My average would still be 80. So even though with all of these the mean is 80 for them, they're very different as far as their median. Here first 2, the median is still 80, but here the median is not going to be, or actually all 3 of these are the medians at 80. Here the median is 0. And the modes are very different for all of these. So they're very different sets of numbers here that we have. One of the ways that you can kind of, when you don't know exactly how many numbers you were talking about, but if you're going to say you have an average of 80 and it really depends who answered what, is we can look at a topic called the standard deviation. And so we're going to be looking at how do you know if something's spread or not. The standard deviation uses not only the mean, but it also uses each piece of data to arrive at a measure of the spread that we can use to describe the average distance from that mean. So the standard deviation is a measure of how far the numbers in the data set deviate from that mean. So let's talk about just how do we calculate this by hand. Maybe in class we'll see if I have a video to show it too. But let's just talk about it. So we have a set of data here. 15, 23, 17, 15, 25, 16, 28, 37. And what I would do first is I would find the average. And we're going to be using this picture here called X bar. And X bar is the mean or the average of all of the numbers given. So I'd add up all of these numbers and I'd divide them by 8. Okay? Now, when I add up all the numbers and I divide by 8, I get an answer of 22. 22 is my mean. So now I want to find the standard deviation. Well, this is my equation here, and we have standard deviation is usually shown by this lowercase sigma, and you might have seen sigma. They actually have an uppercase sigma. Oh, I thought I had an uppercase sigma. Don't we have a, no, we don't. Anyways, uppercase sigma looks different than a lowercase sigma, but they're both called sigma. So our standard deviation is shown by this kind of confusing formula, but let's go through the steps. What we do is you'd first start by writing down all the values. So I have all the values written down here. Then you say how far off is your value from the mean. So 15 minus 22 would be -7 off. Here 15 minus 22 again -7, and these are all the values. Now this column should always, this middle column here should always add up to 0. Then I'm going to take each of these answers and square it. So -7 squared is 49. -7 squared is still 49, 36. Okay, so I squared them all. Then I added that column up. So these are the squared differences. So when I add all that column, I got 430. When I take 430 and divide it by 8, I get an answer of 53.75. Now, in the video that I might show in class, it actually doesn't divide it by 8, but it divides it by 7, or n minus 1. So 8 it was given by the number of values we had to begin with. And this is a difference whether you use n or n minus 1 is whether you have a sample set or you have a finite set. In other words, if I wanted to find out what the standard deviation is for a class that I gave, or a test to, do I have everyone's tests done, or did I just grab the first top 10 tests and I said, well, that's a good sample, and I took a sample. So it kind of depends if you have a sample or if you have all values. We are going to use and assume that we always have all values for all the problems we're given. So we have this sample here, and or excuse me, finite space. So we take that column total here of the square of the differences, and we divide it by how many numbers we had originally, and that's my variance. So this is kind of the average of the difference squared of all the values that we started with. That square root of that variance is the standard deviation. So in this case, it's 7.33. Well, let's see it in action. I think that's going to help us a little bit more. So what we're doing when we're finding the standard deviation, we start simply by finding the average, or not average, sorry, the mean, which is the average. I shouldn't, yeah, we are looking at the average there. So we start by saying, what is our mean? And then we go through each individual value that we had, and we say, what is the difference between the mean and that value? Then for each of those individual values, I find the square of that difference. Then finally, I take that and I divide it by how many values we have, and I took the square root. Again, might be a little confusing, but let's do it in action. So here, we have a set of values. We have 18, we have 21, 25, 29, 31, and 36. I bet I forgot one. I forgot one. I apologize. I forgot a 21. Sorry about that, guys. All right, I had two 21s. That'll throw you off. And you do have to be careful. It is easy to get off when you're, get off by a number here or there when you are doing a list of numbers, okay? So the next thing I would need to do is calculate the mean of all of these. So I'd add up all of the numbers and divide by 8 because there are 8 numbers. My mean happens to be 26.9, okay? So now I'm looking at the difference between the value I had and the mean. So what here is, what's the difference between 18 and 26.9? I got a negative 8.9 here. Here, the difference between 21 and 26.9 is a negative 5.9. Same thing here, it would be negative 5.9. This would be negative 1.9, 2.1, 4.1, 7.1, and finally 9.1. So here it would be like 29 minus 26.9. So that's why we get a positive value. So even though you have a negative value, when you square it, it becomes positive. Now these all add up to really close to 0. We go to 0.2, and it shows that first of all I rounded here. It'll take it off by a little bit, but 0.02, it comes really close to 0. So I'm comfortable with our values that we came within a really acceptable range here. So then when I square it, negative 8.9 times negative 8.9, I got 79.21. When I square this value, I got 34.81. 34.81, 3.61, 4.41, 16.81. Now these would be smaller the closer the mean is to the value. So the smaller the square root would be because you'd have a smaller difference there. 50.41, 82.81. And then I added it all together, 306.88. Okay, so now what I need to do is I need to take that 306.88, 306.88, and divide it by how many numbers I had. And I had 8 numbers there. And then I'm going to take that answer and take the square root of it. And so I had, I don't know, it was around, it's approximately, I don't have that answer, it was about 37. And when I took the square root of it, I got 6.2. Okay? So that is how you find the standard deviation kind of by hand. And I know it's considered kind of a long way. Let's talk about how you do it if you have a calculator in front of you and how you could use your calculator. So here's our standard graphing calculator. You'd first want to put a list into your computer or your calculator. You first would clear, I would clear this to get the list taken off. All right, I'm going to put the same list in. I have 18, I have two 21, so I'm going to hit 21 twice. I have a 25 and a 29, 31, 34, 36. So there's my list. There's my 8 numbers. Now I'm going to get out of there and then, sorry, second quit. And then I'm going to go back to statistics, but this time I'm going to calculate, and I want to calculate the one variable statistics. So I'm just going to hit enter, and my list is in list 1. So I'm going to say I'm going to go calculate please the one variable statistics of list 1. Now last week before we had spring break, we talked about, okay, this is where we get our 5-number summary from. When we go hit the down arrow, and it's that last 5 information, that's what gives us a 5-number summary. Here is what we're going to be dealing with. Like in the first value here, you have x bar, it's to 26.85. Right underneath that, that's the summation of x. In other words, when I added all the x values together, all the original numbers together, I got 215. The summation of x squared would be that second or third column that we had before, 6,085. This s would be our variance, the 6.62, and then that would be 6.62, would be if we had a sample size. So the S of x would be if it was a sample size, which means you're dividing by a 7. And then the sigma x is if you had a finite size, which we're going to be looking at our sigma. So our standard deviation is the 6.19 or 6.2, all right, which is pretty much what we got before. All right, look for our next video, which is going to be on the distribution curve.